All right, part 2 of this one here with our sums. Time to sum it up. Okay, write in sigma notation and determine the sum if possible. So we are going to write it in sigma notation. We could also use our little formula there if you'd like, but let's go for it. So I've got 3 over 2 plus 3 over 4 plus 3 over 8 plus 3 over 8. What the heck is happening here? Well, if you're not sure what our common ratio is, you could always do, if you're like, I can't see it, man, you could take 3/4 and divide it by 3/2, which would be the same as multiplying by 2/3 to get my common ratio, which is going to be 1/2. Okay? You could also see that denominator doubling while the numerator remains 1/2. Okay? Which 1/2, the absolute value of 1/2 is less than 1. So this converges. All right. So we can write this in sigma notation. So if I've got k equals 1 all the way to infinity, right? It just keeps on going, My first term is 3/2 multiplied by my common ratio of 1/2 raised to the k minus 1. And I can plug that all into my calculator, or I could take my first term, divide it by 1 minus my ratio, my common ratio of 1/2. In any event, we're going to get 3 for either one. Okay? There we go. First one done. Dope. And like I said before, practice plugging some of these into your calculator because that set of parentheses, I'll tell you time and again, it messes people up. They go outside the parentheses, just out of habit, like, oh, this is so nice. They gave me parentheses. Yeah, you're supposed to stay in them. Okay? Awesome. I'm going to calm down now. I'm very passionate about those parentheses in the summation notation. Okay. What's happening here? Well, I'm going from 1 to 3 to 9 to 27, so my common ratio is 3. Well, the absolute value of 3 is greater than 1, or we could say not less than 1, so it diverges. So we're not going to find this. It goes to infinity, right? The sum is infinity then. So we're donezo on that one. All right. Cool. And if you didn't see it, remember you could always do 3 divided by 1 or 9 divided by 3 to get that common ratio. That can definitely help. If you have trouble with some pattern recognition, it's okay. Sometimes I have trouble with them too. Use those little strategies. Thirsty. I'm going ham on videos right now. This is the third one in one period. I'm going nuts. All right. Determine whether the infinite geometric sequence has a sum. Well, my common ratio in this first one is 2/3, right? That's what's being raised to that power. Woo! So, since the absolute value of 2/3 is less than 1, converges. Awesome. And it doesn't really ask us to find the sum. That's kind of cool, right? So, we're done. If you'd like to try it, here it is. Ready? So I would have, let's see here, my first term, -3 divided by 1 minus 2/3. That's going to give me -9. Or you try plugging it in your calculator. But again, this one didn't really ask for it, so we could have just said if it converges or diverges. Here, 5/3. I think you can already see it. Not less than 1. Diverges. Okay? So no sum, no sum, no sum. Lovely. We're cruising. We are cruising. Hopefully Officer Gregorio doesn't come over here and arrest me for going too fast. Shout out to Officer Gregorio. Clearly I'm going nuts here after the third video. Express the repeating decimal as a fraction in lowest terms using an infinite geometric series. Oh, what? What in the heck are we talking about here, right? What is going on? Okay, how about this? If, and this might be a little bit out of the box, you're like, dude, I would never have thought of that. What if my first term is 0.8, and then I were to do 0.08, and then 0.008, so on and so forth, right? That would get me there if I just kept adding 0.08 and then like one more decimal, right? Well, what's happening from 1 to the next term? Well, my common ratio here is I'm multiplying by 0.1, right? I'm dividing by 10, right? 1/10. So I've got a first term, I've got a common ratio. I can write the sum here, easy peasy, right? So this, now I can write this as a nice reduced fraction in lowest terms. So my sum would be the first term, 0.8 over 1 minus 0.1. And that would end up giving me, if you were to, you'd have 0.8 over 0.9, or yeah, 0.8 over 0.9, which would be 8/9. And if you did 8/9 in your calculator, I get 0.8 repeating. Look at that. That's kind of cool. Never would have thought about that on my own, but definitely very cool, right? I mean, maybe some of you might have thought of it. I don't know. All right, how about the next one here? Well, let's see. I'm going to take this part right here, the decimal, okay? So I've got 0.90 plus, and then we'd move 2 decimals, so 0090, and then 4, right? So then I'd have 1, 2, 3, 4. There we go, so on and so forth, right? Okay, same kind of idea. Except now, how am I going from 1 to the next? I'm multiplying by 0.01. Okay, but I still got everything that I need here. So my sum is going to be 0.90, 1 minus 0.01. So that's going to be, if I plug that in, I'd get 10/11. Literally paused the video and then started it right there. Okay, 10/11. So then with the initial 7, I would have 7 and 10/11. That's cool. That's pretty dope. It's pretty dope. I like it. Awesome. Awesome sauce. It's a little more naughty today, so I am about to have some awesome sauce. Okay. Find the first 3 terms of an infinite geometric series with the sum of 81 and a common ratio of 1/3. Find the first 3 terms. Okay, there's a sum of 81. Oh, this is probably where that formula would actually come in handy. So the sum is equal to that first term over 1 minus the common ratio, right? So I know my sum is 81. The common ratio is 1/3. So I could solve for my first term then. So the formula is very important. Yeah, I can use my calculator when I know everything, but then to do a little bit of algebra with it, I need to know the formula. All right, so Katoa, I'd have 81 equals a sub 1 over, that would be 2/3. So I'm going to, if I'm dividing by 2/3, I would multiply each side by 2/3 to get it out of the denominator. Now, 81 divided by 3, that's 27 times 2 is 54, is equal to a sub 1, right? Okay. So that's my first term. Then I need, that's good. And then I need my next term. My common ratio is 1/3, so what's a third of that? So I'd have 54. Then a third of that is 18. Then a third of that is 6. And it just wants the first 3 terms. Done. Set up the formula, plug in what we know, solve for what we don't. Just, some hefty algebra. Okay. Ooh. Well, these look rather interesting. All right, so this next one looks a little bit terrifying, yes? What is the value of x if the series x squared minus x cubed plus x to the 4th minus x to the 5th plus ... converges to x over 5? Now, when reading that, you might be like it goes to x over 5? No. The last term is not going to be x over 5. When it says it's that sum converges to x plus 5, meaning adding and subtracting, putting all those together will give you x over 5. That's not one of the terms. That's the sum of that convergent series. Oh, so that's what the sum equals. So that means that I could say x over 5 is equal to x squared divided by 1 minus my common ratio. What's my common ratio? Well, if I go from x squared to negative x cubed, I'm multiplying by a negative x. And then if I do it again, I get to x to the 4th. So negative x. You could also go about it in the same way we've done other ones. I could do x to the fourth divided by negative x cubed. That's negative x when simplified, right? That's my common ratio. Cool. So, and you could have done that with any pair, just take the previous. All right, let's do some simplification. So I'm going to have x divided by 5 is equal to x squared over 1 plus x. And now, what could I do here? I guess we go ahead and cross multiply, right? So I'd have 5x squared equals x plus x squared. All right. And then it looks like I'm dealing with like a quadratic situation, right? So I'm going to set everything equal to 0 because that's what I've always done with quadratics, and it hasn't failed me yet. All right. So subtract the x squared to get 4x squared minus x. GCF situation. So if I take out an x, I'd be left with 4x minus 1 equals 0. So x equals 0, and then x equals, add 1, divide by 4, I get 1/4. Okay, cool. So x would equal 0 or 1/4. I love it. Cool. Nice. I guess when you look at 0, you're like 0, it's like 0, 0, 0. It's going to be 0, but 0 over 5 is still 0. So I guess, works out, adds 0. 1/4, if you did that, it would end up working out to what, 1/20th? But it will work. Cool. All right. What must be true for a series to converge rather than diverge? Do we remember? The absolute value of r must be less than 1. All right. Absolute value of r must be less than 1 in order for it to converge rather than diverge. All right, next up we got the interval of convergence and the sum expressed in terms of x for that series. So 1 plus x squared plus x cubed plus so on and so forth. Now, to find an interval of convergence, we're saying between which value there will it converge, okay? So my common ratio has to be between -1 and 1, right? It has to, the absolute value of my common ratio has to be less than 1. So between -1 and 1. But what the heck is my common ratio here? Well, remember how we talked about you could take a term and then the previous one, divide it by the previous one. So let's do that. R equals x divided by 1, so that would be x. And the same would hold true even if I did x squared divided by x, it's still going to be x, right? And we know that we want the absolute value of r to be less than 1. Okay, so if I know that r is x in this case, because I've already solved that way, I'm going to take x and put it between 1 and -1. That would mean that my series will converge as long as my x value is between -1 and 1 for this particular one. Okay, so my sum is going to end up being my first term, which is 1 divided by 1 minus x, and there's my sum in terms of x. That one seems like, because x and r, it's the same, like, let's try with the next one here. Okay, I think something with a little bit different would help. So if I take x minus 2, so r is going to be x minus 2 divided by 1, right? Take the 1 and then, or take one of the terms and then divide it by its previous. Even if I did that with x minus 2 squared divided by x minus 2, I'd still get x minus 2. So I want that to be between -1 and 1 to make sure that that series converges. So now if I solve this inequality, I'd have, let's see here, 1 and 3. Cool. All right. And then my sum, well, I'd have 1 over 1 minus x minus 2. Simplify that, I'd get 1 over 1, distribute that would be 3 minus x. All right. There we go. Lovely. Uno más. All right. So let's see here. An athlete is able to jump forever. However, every time she jumps, she gets a bit more tired, and every jump goes half as far as her prior jump. Now, for her first jump, she goes half of a foot. Then on her second jump, so she goes half a foot. On her second jump, she goes a quarter of a foot. And then the next one, she'll go an eighth, then a 16th, so on and so forth. How many jumps will it take for her to travel 1 foot? Well, if you remember when I pulled out the tape measure, I can't remember what video that was. But anyways, I think it was this one. We keep going, keep on cutting it in half, basically, and then it's just going to go blah, 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 forever and ever and ever. Well, hold up. Let's see here. If I did my sum of an infinite, because she can go forever, I'd have 1/2 divided by 1 minus, what are we going down? We're multiplying by 1/2 each time. That doesn't that equal 1/2 divided by 1/2? That's going to equal 1. So that means forever. Infinity. Woo! That was a weird there we go. That's a little better. I like that a little better, right? It's gonna take her infinite amount of jumps to travel 1 foot. I guess we'll just have to wait. Okay, awesome. Hope you guys had a wonderful day. Enjoyed the video. America, freedom, rock and roll, Costco, Riverdog, Jane and the Gram, and Yo-Ro. Later.